This video deals with the gradient at a point on a curve. We've dealt with gradients of straight lines. Now we're going to look at the gradients at a point on a curve. And there's a procedure for doing so. So if you're given a curve, like this, for instance, on a graphical plot, so you have your plots. This is just a rough sketch. Say, for instance, you're given this curve, and you're asked to find the gradient at this point here, circled, well, dotted in blue. Well, the procedure is to first draw a tangent to the point on the curve. Remember, we're trying to find the gradient at a point on a curve. So you draw a tangent to the point on the curve. You draw a tangent line. That means a line that touches that curve at just one point, where that point is the point at which you want to find the gradient. So I'm going to use a different color for that actually. This is just a rough sketch. So a tangent line, and then you determine the gradient of the tangent line. The gradient of this tangent line is the gradient at the point. The gradient of the tangent line to a point on a curve is the gradient at the point on a curve. Now we've dealt with gradients of straight lines. So essentially, in order to determine the gradient at a point on a curve, the only new thing you need to be aware of is that you have to draw a tangent line to the point on the curve. After that, you just use what you already know about gradients of lines, because a tangent line is a straight line. And remember, if the points x1, y1 and x2, y2 lie on a line, the gradient of that line is given by this formula, where m represents gradient. Y2 minus y1 divided by x2 minus x1 is the same formula we use to determine the gradient of straight lines. It's the same formula here. So there you go. Here's an example question, and it says, determine the gradient of the curve shown below at point P. Tangent to P has been drawn and labeled for you. We have a curve here, a quadratic curve, and there's a point here, P. So I'm going to make it more obvious. This point here is P. And we're asked to find the gradient at point P. Point P lies on the curve. In order to determine the gradient at a point on a curve, one has to draw a tangent to the curve at that point. Now, the tangent to the point P has already been drawn. And as we can see, point P obviously lies on the line because we drew a tangent. So imagine you have a curve and you have a point. This point lies on the curve. If I draw a tangent to the curve at that point must also lie on that tangent. So we have a tangent line, this line in blue, and we know the coordinates of 2 points on the tangent line because we're also given that the point 5 minus 2 also lies on the tangent line. Now, the gradient of the curve at point P is equal to the gradient of the tangent line at point P. So all we have to do is find the gradient of the tangent line at point P. And the gradient is given by the formula m is equal to the gradient of a line, a straight line, when you're given 2 points, given by this. Now we need to assign x1, y1, this is the first point, and x2, y2 to certain points. Now let P be x1, y1. Therefore, x1, make this more comprehensible. X1, y1, I'm saying let that be P, so that's 712.712. And let x2, y2 be 0.5 minus 2. So this means that, we want to find m, the gradient. So we need y2, y1, x, and x1. So from here, we can tell that x1 is 7, y1 is 12, x2 is 5, and y2 is minus 2. Therefore, the gradient of the tangent to point P is y2 minus y1 minus 2 minus 12 divided by x2 minus x1, 5 minus 7, which gives minus 14 divided by minus 2, which you can simplify to give 7. So the gradient is 7. The gradient of the curve at point P is 7. The gradient of the tangent line to the curve at point P is also 7. Remember, the gradient of the tangent line to a curve at a point is equal to the gradient at that point on the curve. So what we did was find the gradient of the tangent line. We got that to be 7. So the gradient of the curve at point P is also 7. And if you notice, this gradient has a positive value, 7. 7 the same thing as plus 7. And if you look at the line, you can tell that by inspection it should have a positive slope. So our answer is consistent with what the line looks like. We're going to try another example. In this example, the question is exactly the same. It says determine the gradient of the curve shown below at point P, and the tangent to the curve at point P has been drawn and labeled. Now, as you can see, the tangent line is this blue dotted line, and 3 points, in case it's not clear, 3 points on that line have been given. This is 1 point with coordinates minus 113. This is another point, point P, with coordinates minus 2 and 7, and another point with coordinates minus 3 and 1. So we have our curve, we have the point P. The tangent line to the curve at point P has been drawn. So what we need to do now is just determine the gradient of the tangent line. The gradient of the tangent line will give us the gradient of the curve at point P. Now in this case, we've been given the coordinates of 3 points that lie on the tangent line. But in order to determine the gradient, we only need 2 points. We only need some point x1, y1, and another point x2, y2. We only need 2 points. I'm going to pick any two to determine the gradient. The gradient of the tangent line is given by this. So for instance, say we decided to use the point minus 3, 1 and the point x2, y2 as minus 2 and 7. The gradient will simply be given by y2 minus y1 over x2 minus x1. So 7 minus 1, because 7 is y2 and 1 is y1, over x2 minus x1. So that's minus 2 minus x1, which is minus 3. 7 minus 1 is 6, minus 2 minus 3 is minus 2 plus 3, which is 1. So the gradient is 6. Now if I, instead of using this point and that point, if I use P and this point, we'll get the same gradient, and I'm going to show you. If we said let x1, y1 be minus 2, 7, and x2, y2 be minus 113. Just in case it isn't clear, to find the gradient of the line, we only need 2 points, and I chose to use these two, this one and that one. This time, I'm going to use the other two, a different set of 2 points. Why? Because I just want to demonstrate that it doesn't matter which 2 points you pick. As long as you pick 2 points that lie on a line, you get the same gradient regardless of which 2 points you pick. So we're going to do the same thing here. The gradient is y2 minus y1. So here's y2, 13, minus y1, which is 7, divided by x2, which is minus 1, minus x1, which is minus 2. So x2 minus, what's x1? Minus 2. And this gives 13 minus 7, which is 6, divided by minus 1, minus 2, just minus 1 plus 2, which is minus 1 plus 2, which is 1. Again, we have 6. The same result, but we use different points. So when you have a straight line, to determine its gradient, you just pick any 2 points and use their coordinates to determine the gradient. It doesn't matter which 2 points you pick. Any 2 points will give you the gradient.